What's up, Raiders? In this video, I want to talk to you both about first how you can identify a specific angle pair, and then the extension of that is once you've identified the angle pair, what trait is true about them, what's true about their measurements. So while there's several different angle pairs that we can identify, the good news is there's really only two possible things that can be true about their measurements. The angles are either going to be congruent or the angles are going to be supplementary. They would add up to 180 degrees. Those are the only two possible things that are going to be true about the different angle pairs that we're going to identify and work with. And so generically, if we're talking about angle A and angle B, just a way to denote two different angles, we're either going to have the general relationship that the measure of angle A equals the measure of angle B, if we're creating an equation to analyze the angle pair, or if the angles are supplementary, their measurements have to add up to 180 degrees. So we'd say the measure of angle A plus the measure of angle B equals 180 degrees. So while we are going to identify several different angle pairs, don't get nervous thinking that you have to remember some unique trait just for that one specific angle pair. They're going to fall into one of these two categories. All right, so let's dive in. First, and the most common type of angle pair that we end up with is vertical angles. And vertical angles are formed anytime you have an intersection of two line segments or rays. So when you have an X like this, you have 1, 2, 3, 4 individual angles formed. So let's generically say here's angle A and here's angle B. Well, these angles that are across from each other in the intersection, these are vertical angles. And if you look in terms of their characteristics, they share a vertex. What I'm filling in right now is the vertex here. This is the vertex for angle A, and at the same time, it's also the vertex for angle B. But that's all they share, because angle B is off by itself on the right here. There's its two sides, and angle A is to the left. So they don't share any sides or anything, they just share that common vertex. And what's always, always true about vertical angles, their measurements are equal. The angles are congruent to each other. So if we had an algebraic expression for angle A, that was 4x plus 10 degrees, and we had an algebraic expression for B, and it was 3x plus 20 degrees, well, the equation that we could create based off of the characteristic of the angle measures of vertical angles is we could say that 4x plus 10 equals 3x plus 20. And then you can solve that from there to get what x equals, substitute it back in, and then you can get the measure of each angle. So that's vertical angles. Next up, let's talk about corresponding angles. Corresponding angles occur when you have a slightly more complicated scenario. Vertical angles, anytime you have an intersection of two other line segments or rays, that's enough to identify vertical angles. Corresponding angles and several of these other angle pairs that we're going to do soon, it's a little more elaborate. Let's say we have two segments like this, but they're not intersecting one another. Now we have a third segment that intersects not just one of them, but both of them. This is referred to as the transversal. Transversal just means a line segment array that doesn't just intersect one other line segment array, it intersects two or more. So now with a slightly more complicated diagram, this opens up some more angle pairs. So let's say we had angle A right here, angle B right there. Now if you look at this, let's just focus on the upper portion of this diagram. If we look, this looks like the vertical angle scenario that we took a look at earlier. We have 1, 2, 3, 4 individual angles. So ignoring the bottom intersection, we could refer to this location right here as the top left of this intersection. This would be the bottom left of this intersection, top right, and bottom right. So generically, we could say angle A is in the bottom right spot out of that intersection there. Well, now shift our focus down here. We have kind of a recurring pattern where intersection of two segments here, 4 individual angles formed. Here's the top left spot, bottom left, top right, bottom right. So in this case here, angle A and angle B are both in the same matching or corresponding locations. And in this case here, if these two intersected segments are parallel to each other, then these angles would be congruent to each other. So if we had an algebraic expression like 2x plus 40 degrees for angle A, and 3x minus 10 degrees for angle B, we could then create an equation to help us analyze this setup and figure out what each individual angle is. We would say 2x plus 40 equals 3x minus 10 because the angle measures are equal to each other here, and then solve that and go from there. Moving on. Now we can talk about alternate interior angles. And again, this is a little more complicated of a setup. If you notice, the name has two parts to it, alternate interior. So there's multiple conditions that have to be true to have a pair of alternate interior angles. So let's say we have two segments here, but again, they do not intersect each other. But we have a third segment going through them. Again, this would be the transversal because it doesn't just intersect one other segment, it intersects two or more because it intersects here and here. So now, if we have angle A here and angle B here, let's see why these would qualify as alternate interior angles. Well, the alternate part of alternate interior, here's the transversal. Angle A is to the right of the transversal, angle B is to the left of it. So they're on opposite or alternate sides of the transversal. That's the alternate part of alternate interior. And then look at your two intersected segments. If you notice, angle A and B are on the inside of these two intersected segments. So putting it all together, angle A and angle B are alternate interior angles. Now, if these intersected segments are parallel to each other, then alternate interior angles are going to be congruent to each other. So if you had an algebraic expression for A that was 2x plus 20 degrees, and an algebraic expression for B that was 3x minus 5 degrees, well, if these angle measures are equal to each other, then the equation you could create is 2x plus 20 equals 3x minus 5. Solve the equation from there, and you can figure out each individual angle measure. Moving on. Now let's talk about alternate exterior angles, which basically just goes a step beyond alternate interior angles, and it will tie into vertical angles that we already talked about. So I'll create a similar setup to what we just had for alternate interior angles. So I have two segments here, but they're not intersecting each other, but I'll put a transversal here. Again, it's a transversal because it intersects two or more other line segments or rays. Here's the transversal. So let's build this alternate exterior angle here by first identifying the alternate interior angles like we already looked at earlier. A and B would be alternate interior angles. Angle A is to the left of the transversal, angle B is to the right of it, so they're on opposite or alternate sides of the transversal. And A and B are on the insides of the intersected segments. So those would be alternate interior angles. Well, let's build off of that and let's take a look at vertical angles that we already identified. We know here would be vertical angles, and vertical angles are congruent to each other. So if this one's labeled angle B, we can call this one angle B. Well, here we have vertical angles as well. If here's angle A, then this could be labeled as angle A as well. Now putting this all together, now look what we've done with the new angle A and angle B we've put in. They're alternate exterior angles because they're on alternate sides of the transversal. A is to the right of it, B is to the left of it. And if you look at the intersected segments, these new angles A and B that I just put in here, they're not on the inside anymore, they're on the outside or exterior. So these are alternate exterior angles. And if the intersected segments are parallel to each other, then these alternate exterior angles will be congruent to each other. So let's say we had here, this was 3x degrees, and angle A, the algebraic expression for it was 5x minus 40 degrees. Well, if these angles are congruent to each other, their measurements are equal, so an equation we could create would be 3x equals 5x minus 40 degrees. So all these angle pairs that we've identified so far all have the same situation that their angles are congruent to each other, in some cases all the time like vertical angles, or in some cases it's conditional like with corresponding angles, alternate interior angles, and alternate exterior angles, but they're always congruent. Well, we have some angle pairs that are not congruent, but they're supplementary. So one of the easiest ones to take a look at is a linear pair. We know that anytime you have a straight line segment array, that there's 180 degrees all the way across. Well, if we take that straight segment and we split it up into two smaller angles, like angle A and angle B. Now notice here, the way we've done this, angle A and angle B, they share a vertex. This is the vertex for angle A, and at the same time is the vertex for angle B, and they share a side. This side here is simultaneously part of angle A and it's part of angle B. So to identify a linear pair, if they share a vertex, they share a side, and collectively when you put them together, they make a straight line segment array. Collectively, we would call them a linear pair. And going all the way across, they'd have to add up to 180 degrees. So if we had to set up something like, if this is 3x degrees for angle A, and then angle B is x minus 20 degrees, and these angles, because collectively they make a straight segment that has to have 180 degrees, they're supplementary. The equation we could write then is 3x plus x minus 20 equals 180 degrees. Solve that from there, and then you could figure out what each individual angle measure is, and collectively they'd have to add up to 180 degrees. One last angle pair I want to take a look at today. So we'll take a look at same side interior angles. If you notice, the format of that name is similar to the alternate interior angles that we talked about, and so you'll see that kind of recurring theme. So if we have a setup here, something like this. Here's angle A and here's angle B. Here's our transversal, because this is the segment that intersects two or more other segments. And angle A is to the right of the transversal. Angle B is to the right of the transversal. So they're on the same side of the transversal. And at the same time, angles A and angle B are on the inside of the intersected segments. So collectively, they're same side interior angles. And if you look visually, they certainly don't look like they would be congruent to one another. Angle B clearly looks acute, something less than 90 degrees. Angle A looks obtuse, more than 90 degrees. And if these intersected segments are parallel to each other, then these angle measures are going to be equal to each other. So if we had they're going to be supplementary. So let's say, however many degrees this was, however many degrees this one was, we could generically just say the measure of angle A plus the measure of angle B. Collectively, these two angle measures added together has to equal 180 degrees. So whatever your algebraic expressions for these two angles are, substitute them in, set it equal to 80 degrees, 180 degrees, and there you go. So like always, if you have any questions, reach out to me. Take care.